Okay. So, welcome everyone. Welcome to those who see us synchronously or asynchronously. We are here with Lectures Without Borders, and we are concluding this week of our lectures for Kazakhstan for the first time with a lecture by Professor Dr. Nigel Mason. He's actually a professor of molecular physics in the University of Kent, UK, but his research has led Nigel to leadership roles in many national and international research programs. And he's currently president of the Europlanet Society, Europe's largest forum for planetary sciences. He has formed, among others, the molecular physics group at UCL and the astrochemistry group in the Open University, both in the UK. And he has studied from chemistry in the Earth's ice to ice in planetary surfaces and on dust grains in the interstellar medium. This is just some of the things he has studied. So he can be identified as an astrochemist and planetary scientist. He has over 350 publications, and he is active in many fields, among which astrophysics and astrochemistry, environmental and atmospheric physics, plasma physics, and nanolithography, and also radiotherapy, next generation radiotherapy, an adjacent topic. But today he's going to talk to us about the future settlements of humans on Mars and on the moon. So the floor is yours, Nigel.
Thank you very much. Let's get the slides up without any further ado. Just hope they come up. Let me know that they do.
Yes, it's showing.
And we'll get into the full screen mode. Well, good evening, everybody, and thank you for joining tonight in Kazakhstan. I haven't visited Kazakhstan, so I hope to maybe one day. What I'm going to talk about in the next 25 minutes, and then we'll have plenty of time for questions, is the next era of humanity. We are in an incredibly exciting time. It is now likely and that in the next few years, we will not only return to the moon, but we will start to do something which humanity has never done before, and that is settle and have permanent bases outside the Earth. In your lifetime, this research will develop, and maybe when you're talking to your grandchildren in 40 or 50 years' time, you'll be able to explain to them, reflect to them how much the world has changed because humanity has become an extraterrestrial species. In Europe, this program is coordinated by the European Space Agency, and the director of the European Space Agency made a famous statement now in the 30th of October last year, stating that the European moon base, the first permanent structures on the moon, will happen, and the first infrastructure will be in place within a decade, despite current geopolitical problems. And we're preparing to go to Mars. So what I'm going to talk to you about in the next 20 or 25 minutes ago is a little bit about the details of that, the challenges that we face. But I'd like to begin by, of course, recognizing that you're in Kazakhstan. You are one of the space portals. From Kazakhstan, humanity goes into space in the launch site at the Baikonur Cosmodrome. And you have your own satellite program. The National University is making CubeSats. And so within Kazakhstan itself, you have a very active space program. And maybe some of you had the opportunity to participate in that or will in the future. Now, as I said, humanity is going into space. As of today, only 676 humans have been into space. Only 73 of those are women. They come from 44 countries. 3 of those have come from Kazakhstan. And I'm sure you know about them. And I know they're on your, they have had stamps made of them, and there are lots of websites about their lives and everything else as an example to you. Only 24 of those humans have walked on the moon. So as we now think about going back to the moon and beyond to Mars, you can see how few have had that experience, and indeed how little experience we have of putting people there. But as I said, this is going to change in your lifetime. We are going to go into space. But we're not going into space just to explore it, just to say we've been there and plant a flag or bring back some rocks. We plan to stay. We plan to build bases and settlements in space, which will be permanently crewed. And that the next history of humanity will be to have these permanent bases in space. This will begin in 2028 with NASA deploying what they call a lunar surface asset. It's a small habitat which can be dropped to the moon. You can see it here. It's just literally a cabin. But it will be the first things that we don't just land on the moon, walk around, plant a flag or two, and then take off. People will go down, they'll stay, they'll do something, and then they will come back later. And the first thing that we will probably do is astronomy. We will build the first lunar observatory on the far side of the moon and at the North and South poles, because there we can do science we can't do on Earth. The Earth is actually a very noisy place if you're trying to measure radio signals or something. We just have too much clutter, too much noise. But we can go to a quiet space, looking out into space, which we haven't without that noise, and we'll be able to pick up signals and look at things we can't do. Indeed, we might be able to detect gravity waves, which are fundamental to our understanding of how the whole universe founded from the Big Bang onwards. And also the moon's days and nights. A lunar day is basically you have 14 Earth days. So you have a lunar day, and then you have a 2-week lunar night. But that means you have a dark sky, not for just 1 or 2 hours, but for several days, which means you can detect very weak optical signals as well. So that's the moon. Why do we want to go to Mars? Well, I think you had a little bit of astrobiology lectures earlier this week. Mars is the first place where we believe there may have been life, or there may indeed be life, extinct and extant life. The discovery of another life form on a planet not our own will be one of the sea changes of humanity and our understanding of who we are and where we are. But even if we don't find life, we can learn a lot about Mars, which in many ways was very similar, born at the same time as the Earth, had water and so on in its early days. If we want to understand how planets form and something about them, Mars is good for that. And as we expand our studies to exoplanets and we think about whether life can be on any of those planets, we need to study another planet other than Earth. And that's one of the main reasons for going to Mars. But people are also thinking about having permanent settlements on Mars. And what will they do? Well, for instance, they might mine the 2 captured asteroids, which are the moons of Mars. They might be able to look for precious metals so we don't have to wreck seafloors on Earth. We might be able to do somewhere else. But most of all, it will be the step on humanity becoming, as I say, an extraterrestrial beyond Earth species. But it's not going to be easy. And so I want to give you some of the difficulties about going into space, living in space, working in space, and building in space. So when you go into space, you have many things. First of all, you lose gravity. And space is also a vacuum. The moon has no atmosphere. It has nothing to protect it from meteorite impact. Nothing burns up in the atmosphere. Space is also very cold. And it's also full of radiation. So if we're going to live and work in space, we have to tackle all of these problems. But we've also got other problems. How are we going to get there? What type of rocket are we going to build? And if we're living there, what are we going to eat? So let's just look at a few of these things. So you all know that once you're in orbit, the spacecraft and the space stations, the astronauts experience weightlessness. And if you talk to astronauts, those first experiences, it seems fun. But already the astronauts' bodies are changing. So if you look at an astronaut on the space station, you will see their face doesn't look the same as it does on Earth. It's what we call puffy face, because the blood flow is not being restricted by gravity. So some of the blood comes up and some of the fluids come up and you get a more puffy face. Now, that may not seem terribly bad, but the other problem is for your space for any time. Your body is conditioned to work under gravity conditions. So the muscles in your legs and in so on weaken. And so ultimately, after a long period in space, when you come back down to Earth, you may have seen this when they take the astronauts out, they can't stand. Their muscles have become so weak that when they return to Earth, they're no longer able to do basic things. It takes them a long time to recover. But it's not just that. There are other things, as this slide shows. Your bones become brittle in space. Your heart muscles are no longer working as they do on Earth, and so your heart muscles may become weaker. As I said, your muscles become weaker. And there may be other problems in terms of your system. So bone density is a big issue. If you're going to live in space for a long time and you're going to work in space a long time, you're going to go to Mars for a long time, your bones may become brittle. Now, if you break your arm on Earth, you can get it replaced, get it healed relatively quickly. But imagine you're an astronaut with a broken arm or a broken leg, much more difficult to consider. But the likelihood of having those injuries will be much higher in a low gravity environment. We also know that the space environment affects the nervous system and affects the brain. It affects the way that your body clock works, the biological clock, the sleeping pattern of the astronauts. And if any of you have had 3 or 4 days without sleep, you will know that will affect your mood and it will affect, etc. And if there are only 4 astronauts locked together and you're having a bad day and you're arguing with each other, it's not good. And then, because your body has this basic idea of gravity, things going down, if you don't have that, you will experience dizziness. You'll have basically like a motion sickness, like seasickness. And your visual concept, the way that you see up and down, starts to break down in space. And the space moon sickness is experienced by about 50% of all the astronauts. And it makes you nauseous, it makes you sick. And you can imagine that that's not good in a spacecraft. The human body has evolved gravity. On the moon, we have almost very little gravity. On the Mars, a little bit more, but we'll have to take that into account. The second major problem when we take outside the Earth is we go into an area where we're basically being irradiated all the time. The astronauts are exposed to ionizing radiation from the sun and also from galactic rays dominated by high-energy neutrons. Now, on the Earth, we're protected by our magnetic field. So a lot of that radiation we never encounter. But in space, we have to deal with that. And if you are irradiated, then you will get long-term effects. Your DNA will be damaged, and this leads to cancers. So you have a long period in space, you may then suffer from various types of cancer for the rest of your life. Again, a big risk. We also have extreme events like solar flares. If we have a solar flare, huge amounts of radiation will be enough to kill you. So if you're going to be in a lunar base, or you're going to be on a Mars, or you're going to be in a spacecraft between the two, and a solar flare comes, you need somewhere to go, somewhere where you can be shielded from those solar flares. Otherwise, you may receive enough dose equivalent of Chernobyl or something else, and that may lead to fatalities. And just to give you an idea of why that's important, we can go to the moon in a few days, or to go to Mars, to go to Mars, land on Mars, do some work on Mars, and come back. We're talking about at least a 3-year trip. And that means you've got to survive the conditions in space for 3 years. And as I said, there's a number here that one solar particle event means that you could receive, if there was no shielding on your spacecraft, you will receive enough radiation to kill you in one event. Why does it take so long to go to Mars? Because you have to wait for every few years when Mars is closest to Earth. you depart on a trajectory, so you arrive in Mars about a year later. You then stay on Mars for about a year before you come back. That's the most optimal way of using the least amount of fuel. If we're going to build a base on Mars, then we have all these things to take into account. We have the radiation protection, but we have to think about accidents. As I said, your bones might become brittle, so you need to think about medical surgery. We'll see in a moment, we need to talk about food. What are they going to eat? We need to think about the psychological effect of being isolated for so long. And there have been several examples of that, where people have been locked away in Mars simulated conditions for several months. And that produces a lot of psychiatric issues. And we've got to think about how we're going to build the base, what we're going to do when people are there. It can't just all be work. We want to have some recreation and sport. And of course, people need their privacy. So let's look at what we need to do when we need to build a base. And we'll take the example of the lunar base, because that's what we're going to do now. So what are the two questions about living inside a lunar base? Well, we have to think about the temperature of the lunar base. And we also have to think about the air quality in the lunar base. Human body is very sensitive to temperature differences. It performs within an optimal temperature region. So on the space shuttle, they maintain the temperature between 18 and 27 degrees centigrade. If you're outside that region, then people start to become uncomfortable. But it varies person to person. There are gender differences, there are ethnicity differences of how people's bodies react to different temperatures, depending upon the environment with which they grew up. If it gets too hot and the temperature rises about above 40.6 degrees centigrade, then you will suffer from heat stroke, which will lead to you not only sweating, but also feeling sick and also getting very confused. A confused astronaut making a mistake is not a good thing. Similarly, if the temperature drops below 35 and you get the shivering and so on, then your body can shut down and leads to heart attacks. So the humans can only exist in a very narrow range of temperature without thermal protection. So below 10 degrees centigrade, above 35 degrees centigrade, that's the range you're going to have to work in your spacecraft or your lunar base or anything else. And this does depend on how much water there is as well, and the humidity. The other thing, if you're living in a small environment, is the gases in the environment are going to build up. The fumes are going to build up in the cabin during emission. You can think about some of the emissions that humans give off, but also other things will give off those emissions, some of the materials that were there. On Earth, it doesn't really matter. You're used to just opening the window. You can't do that in space. So recently, ESA had the first power astronaut, a man who basically has a prosthetic leg. He was a Blade Runner, very fit, very healthy. And so it decided to see how he would cope in space. First of all, they found the prosthetic leg didn't work in space because of fluidics. But very surprisingly, they found that all the things that made up that leg gave off emissions. They gave off gases. And so if he stayed in the spacecraft for 6 months, he would basically poison the spacecraft with the emissions from his leg. Now, what about food? The problem of food in space is you can't, if you're going to go on a very long mission, it's very expensive. All space missions come down to basically a fundamental property of weight versus cost. The more you take, the more it costs. When you do a launch, 90% of the mass of the rocket, when you take it off, is fuel and all the things that put fuel together, the rocket casing. So every time you add more weight to the payload, you have to add more weight to get the rocket to take off. That means if you were going to rely on taking all the food with you to space, it would be very expensive. So people are now talking about growing things in space, in the space station, on the moon, and on Mars. We know this field now is called space agriculture. It's growing pardon the pun, developing very rapidly. And people are growing crops basically to see how much of that they could sustain on a base itself. And of course, fresh food is always good. But there are a lot of things to understand about biology. If you're going to try and grow things and make the lunar soil fertile, there are many things that we have in our soil which make plants grow. For example, we have worms to make the soil aerate and let stuff pass through it. Lunar dust and Martian dust are very clingy, they're very clay-like, so you would need something to keep breaking it up. So we're doing experiments here at the moment, putting worms into lunar and Martian simulants to see how they survive. And a little picture at the bottom here are tardigrades, which you probably hear about. Very good if you want to grow mosses and so on as well. So people are starting to think about what people will eat. Plants can be grown indoors. Insects can be taken into space. And there's a lot of work going on around the world, not just going into space, but using insects, making insects into a food that's very rich in protein. But what can grow in Mars soil? What can grow in lunar soil? And this is being investigated now. Is it possible? The answer, of course, is yes. And we have some programs around the world. Australia just recently in Adelaide opened the first Centre for Extraterrestrial Plant Studies, and in Japan. And here in Europe, we're doing the same. Actually, here in Kent, my university here, Kent in England is known as the famous, it's called the Garden of England. It's where we grow a lot of fruit and vegetables for England, going back to Roman times. And so now we're using the knowledge we've gained to growing things on Earth to see if we can think about growing things in space. What are we going to build a lunar base of? What materials will we use? Again, I told you it's so expensive to take everything up there. So why don't we try and use what's there? We want to be shielded by the radiation. So maybe we can use things like the lava tubes or the pits on the moon, where we can build the base underground. So we've got the soil and the rocks above it to shield it against the radiation. But we can't be completely underground because we're going to need the solar power to generate much of the power that we have there. So alternatively, we could use some of the lunar soil. We can make it into bricks and to build it. And this, as you can see here, is a plan of how we would start to build a base. We would start with a small cabin, and then we would start producing machinery, which in turn to make bricks. We might do 3D printing and so on to gradually build up the size of the base by robots. And these are just some of the things to say. What you see here on the right here, this is a lunar simulant soil, which we have, which represents the lunar soil similar. But we can see that we can make big brick structures out of it. So we can use the soil itself on the moon to make the structure. So we don't have to take the material from the Earth to the moon. So where are we? We know how to go into space. We know the science of going into space. We know the risks of going into space and living on the moon. We know, or we think we know, how we can mitigate some of those risks. But now we have to plan technology. We have to develop the technology. But it will happen. And in your lifetime, it will happen. In the next 10 years, we will go back to the moon. The Europeans, Americans, Japanese, the Russians, the Chinese, the Indians will all have astronauts on the moon and will establish space bases on the moon. They will build lunar bases on the moon, both crewed and robotic. And we will do initially science. We're going to send more missions to Mars, initially robotic, to learn more about the landing sites and the places and look for things. We're going to develop and are developing larger, more powerful rockets, capable of traveling to Mars faster, but also taking heavier loads to Mars. But to do that, we have to understand the effects of the radiation in the space environment on the humans and how we can protect them against that. So, what's my message to you? You're in a country that has a space program. You can see wonderful launches. But the space and the space industry is for everyone. There's no reason why you could not work in this area. Just be bold. And if your dream is to be an astronaut, or your dream is to work on putting people into space or work in the space industry, the opportunities in your lifetime will be large. It will be one of the biggest industries, space industry, not only for exploring space, but also using space to help so many things on Earth, the satellites, for looking at the Earth and climate change and so on. All these things will be opportunities for you. I hope that's given you a little guide to going to the moon and going to Mars and where we are today. But I'll very happily now take any questions that you have. Please ask away. Thank you very much.
Thank you, Nigel. We actually have some questions from the students. They came in direct message to me. One is more general. I think it relates to you talking about the observatory at the dark side of the moon, at the far side of the moon, to be honest. So the question is, does the moon rotate? That's the first question from the student.
No, the moon is tidally locked. So that's why the dark side of the moon is never that's why we call it the dark side. We only see one side of the moon here. The other side always faces the other way. Okay, so that's why we don't have to worry about it rotating round. It is permanently facing that way. So we only see one side. And the fascinating thing is the two sides of the moon are very different. They are very different in the way that they're structured, in the number of craters, in the geology, and so on. They're very different. And the most recent mission to that is my little rocket, my Indian rocket. I was in India in the beginning of January. The Indians had a very successful mission where they put the lander on that side of the moon and took some wonderful pictures. And only now we're beginning to try and understand what happened and the history of the moon, if you like. We've got a lot to do, but there'll be a lot of, the Chinese have been there when ESA's going there. We've got lots of opportunities to look at that side, but no, it's always permanently facing one way. It doesn't rotate round. It only faces one. Okay. We have the face facing us.
Then I guess the next question is also related to the moon is how do we calculate lunar days?
Lunar days are because the Earth Moon system is still rotating, so you're still going to have periods where although it's always facing to us, the Earth, it doesn't mean that it's not rotating around in the actual system. It just means that it's what we call tidally locked. So one face of the moon is always facing us, but in the whole system, it's still being exposed to the sun for periods. The lunar day is actually 2 weeks of our time. So a lunar day is 2 weeks and the lunar night is 2 weeks. And that's the big problem. So if we land something and we use the solar energy to run the solar panels, unfortunately, when we go into the lunar night, it also gets very cold. So on the equator, in the lunar day, it can go up to about 150 degrees centigrade. But in the lunar night, it can go to minus 150 degrees centigrade. So the big problem, like the Indian and the most recent Japanese lander, everything freezes, the electronics freezes, and so the batteries don't work anymore, so they don't wake up. And that's one of the big challenges, is to be able to generate things like batteries that will survive this big temperature change.
Okay, interesting. I have a question for these famous tardigrades. So the question is, if the tardigrades that you showed in one of your slides can survive on Mars, what do we know about it?
Right. Well, first of all, on the moon, there was a private company from Israel that had tardigrades on board, and they wanted to explore this. Unfortunately, it didn't land as they expected. It just basically smashed into the moon surface. So here at Kent, we have something called a light gas gun. We can basically accelerate things to high speeds. We normally look at space debris and see the damage it can do on spacecraft. But one of my students here, she actually did experiments by firing tardigrades at high velocity to see if they could survive an impact on the lunar surface. And the answer is that up to a certain speed, they do. And then there's a very sharp transition between being alive and dead. So one velocity alive, next velocity dead. So some things can survive impact. The reason the things we're interested in is if you're going to start to do agriculture I don't know if any of you have what we call the wormery. You know, you tend to have them at school where people want to show you what worms do, and you have a soil, and you might put some coloured sand in the soil, and then you put your worms in, and you see how the worms churn all the soil up, because that's what they're really good for. They aerate the soil. So we're trying to do the same, but putting the worms into a Martian or lunar soil, because it might be that some of the chemicals in the soil, in the case of Mars, it's called a perchlorate, might be harmful and kill the worms. But if you want to grow some moss or some things, tardigrades come with that. You know, you need some of the biology biomes for that. So we're looking at those things now at the moment to see if they could survive those conditions. And similarly, we look at the bacteria to see if bacteria can survive. There's a lot of poo on the moon. When the Apollo astronauts went on the moon, they wanted to bring back lots of the rocks. So to bring back the rocks, they had to leave something behind. So they left their poo behind. Okay, Nobody knows after 50 years whether the bacteria in that poo, what's happened to it. In fact, the Americans have declared their poo a national asset. You can't go and examine their poo. It belongs to America.
That's funny to know.
But at some stage, somebody would like to go and look at the poo and see what's happened to it over 50 years, and see what happened to the bacteria in the poo.
Okay, that's surprising. I didn't know about this. Okay.
There are several kilograms of poo on the moon.
I guess we brought so many kilograms of rocks back, we had to leave kilograms back, right?
Yep, you have to leave one to get the other.
Okay. So this was the questions so far from the students, and I think we are pretty good on time. So I would like to ask you, like, if the moon base you said is going to be like a reality possibly for the students of this class, like which are students now. So how many years do you think it's going to take for a moon base?
The plan for the Americans is to deploy the first sort of space capsule. It's just a cabin, if you like, around about 2028, 2030. So the first bases, the first things that we do, that will sit something on the lunar surface which astronauts can go and visit. So we're going to build something. We're building something called the Gateway, the Space Gateway. It's basically a space station around the moon. So you will take off from Earth, you will go to the Space Gateway, and then you will go up and down from the moon surface, from the gateway. And you will go to your little cabin, and you will spend several days in the cabin doing experiments, etc., before you come back. And that will be the first kind of base that we have on the moon. And then we will start thinking about how to build the bigger and larger structure. And as I say, to do that, we will have to use the local materials. We won't be able to take everything up there. We can build a small hut, if you like. We can build that by taking a more complex system with greenhouses and maybe doing some conversion as a lunar soil and building permanently running computers and so on. We will need a much bigger structure, and to do that, we're going to have to actually build things from the stuff we've got on the moon. Lunar bricks are very the lunar material is a very good building compound. There have been some other experiments if you want to make things bind together, because the lunar soil is very powdery. So again, in space, you want to use everything that's there that's useful. And one of the things that makes materials bind together well is urea, or P.
Mm-hmm.
So people have done experiments of trying to see how strong materials come when they add urine to space bricks. Unfortunately, I have yet to get my students to volunteer to do this. but in America and India, they have tried it. So I have some new students started this year. That is my ambition, that they are building things from lunar materials. I think during their PhD, they need to do the ultimate experiment for mankind.
Okay, that's interesting, because you never know what you need to do as a researcher. You know, we have a lot of ideas that people need, especially for the space science, that they need to be good at math.
As I say, anything you take into space, make use of it.
But everything, yes.
And the poo will be used for for example, as a good manure for the plants, which is again why we need to know about what the bacteria in that and how they behave in space.
Okay. Okay, I think that was the last question. So thank you very much. I'm gonna stop the recording now.